Welcome to Easy Math TV. We're going to do another R lab today. This is a continuation of our statistics series that has to do with lab activities in the programming environment POSIT Cloud using the language R. And this is lab number 4 on our list. So basically when you go to the list of project files and folders, you're going to want to scroll down and look for the one that says probability. So the probability lab is lab 4. And when you open the HTML file, you will see there's actually a lot of explanation with this one. So I'm actually going to highly recommend that you read through the entire thing, read it over a couple of times, and go through the text the explanatory text before you even begin to throw some code into here. And it actually makes the suggestion that we put all of our code into an actual document here inside of POSIT Cloud instead of using the console this time. So what we would need to do there is go to File, New File, and you've got all these different types of files. The one we're interested in is the very top, called an R script file, because that's just R code. That's just straight up R code. And you'll notice that created this new window now. So we now have 4 windows open in POSIT Cloud. We have our file name and file document in the upper left. We have our console in the lower left. We have our environment in the upper right, and we're going to have our plots down here in the lower right in a moment. So that's our plot window, our environment, our file that's going to have all of our code in it. And then the console will still be kind of necessary a little bit, because it's going to anything that prints out like a table or a list of values, that's going to show up down here in the console. All right. So let me just show you really quickly how you would save this. So you get this untitled document just like you would if you opened a plain Word document. And to save it, you're going to just give it a file name, and it'll show you where that file is going to get saved to. So right now we're in the probability folder, so it's just going to get saved right there in that probability folder, whatever name I give it. So for example, I might call it lab4 underscore and then MB Rudis. So like my first initial last name. But you have to actually give it an extension this time. So I have to put the dot and a capital R. All right. So it's going to be lab4 underscore your first initial last name dot and then capital R. All right. And then we hit save. So that showed up right here. It's just an empty document. So actually right there. So you can actually see it's 0 bytes because it's empty. So let me just delete that. Okay. Has been deleted or removed. Yes. Okay. All right. What I'm going to do is I'm going to open the document that I already created that has all of the R code for today's lab in it. It also has some comments. So all of these comments are things that I added in to the document. You're going to want to put your own comments in if you would like. But basically, this is just going to help me get through our video a little bit more efficiently so that it's not too long. Anyway, before you do anything, you're going to want to check your list of packages. So click on the Packages tab and make sure that you have 2 of them. There's one called ggplot2, and that's here. And notice there's a check mark in front of it. And the other one is near the bottom called tidyr. It looks like tdir, but it's tidyr. And if that does not appear, then you actually need to do a search for it in the search bar up here. And then a window will pop up that says it's not there, so you have to install it. But basically make sure that you have those two packages, ggplot2 and tidyr. All right, let's go to the plots window. So now that we're ready to actually work through our lab, we want to have our environment showing. We want to have our plots window. We will be looking at the console a little bit, but we're not going to be actually typing R code in there. The R code itself, capital R code, the code itself is just in this file that we have open. And literally all I need to do is highlight the sections that I want to run. So for example, I might just run these first 4 lines here, download.file, load, and then print the headings, and then show me the first 9 values of something called Kobe $basket. So let me run those and I'll explain to you also what our data is. We are actually looking at all 133 shots that Kobe Bryant made during the finals, the NBA finals in 2009. So in that his performance against the Orlando Magic in the 2009 NBA finals, it actually earned him the title of most valuable player, and he actually made 133 shots on the basket during those finals, during that series. So we have basically, this is just all the different variables here. There are 6 of them. One of them says versus, so that's probably all Orlando. So that, like, basically it's just the number 1. You know, so like you've got Orlando, because they played Orlando. And then you have the game number. So was it game 1, game 2, game 3, so on. And then there's a variable for the quarter. There's a variable for time. So what was the time index that he made the shot? And then there's a description of the shot attempt. So for example, he missed a jump shot. He missed a 7-foot jump shot. So like it's very, very specific in that description. The only variable that we're going to be looking at today, though, is going to be whether he hit or whether he missed on the basket. So that's the basket variable here, $basket. Okay, so those are the ones we're going to be looking at. And what we're interested in, since this is a probability exploration, right, we are interested in knowing whether this theory of having hot hands actually is true or not. You know, like, is there evidence to show that having hot hands, like, you know, can you go on a hit streak, or not? You know, is the probability of getting your second shot determined at all or influenced at all by your probability of getting the first shot? And we've talked about this in class. We mentioned that, like, you know, that a lot of study has been done on this, and that it's been proven that making shots at a basket is considered to be an independent variable. In other words, your second shot is completely independent of what your first shot was, and so on and so on. But we're gonna explore the data anyway, because we actually have some data to look at for that. All right, so you can see down here in the console, I printed out the first 9 values of Kobe $basket, and my expectation going forward too, by the way, is I don't want to see 500 values printed out on a page. That's not helpful. It's not giving me any useful information about the data. So when labs are submitted, I expect to see only included in that submission or in that document, only include things that you thought were actually useful for answering any of the exercises or for understanding what your data was, because listing 500 values of something is not helpful. Showing a histogram of it, that's helpful. Showing a box and whisker plot of it, that's helpful. Calculating the mean and the median and maybe the standard deviation, those are helpful things. Getting summary statistics, all that sort of thing. But listing out 500 things is not helping you at all. You're just kind of like staring at a mass of things. And there's nothing that your brain is going to be able to do to make sense out of that. So at this point, we need to explore what is this idea of since we're talking about hot hands, we want to look at things like a streak. Like what were Kobe's streaks during this series, this game series, in the finals? So like, you know, for example, in these first 9 shot attempts, the directions for the lab actually show you how to separate this data out and look at what the streaks are. So for example, the first one was a hit and the second one is a miss. So the moment that you have a miss, you have ended your streak. All right? So you would actually draw like a vertical line right after that first miss. And that is your first streak. You had a hit and then a miss. So boom, you end. And then the next miss is just kind of a separate thing. That is you can put another vertical line there because that would be considered to be a separate series, right? You have a hit and a miss, which is going to be the first streak, and then a miss only is the next streak, and then the next streak is the HHM because you got 2 hits and a miss, so that's another streak. And then each miss is a separate streak because we're only interested in winning in hit streaks, not miss streaks. So we don't want to like see 3 misses in a row as that's not a streak. So every time you see a miss, you are designating that as a streak. Okay. But I think that the lab directions explain it probably even better than I just did. So using those directions that are in the lab, you're going to be able to answer exercise 1. Within the first 9 shot attempts, it says there are 6 streaks, okay? The HM is 1, then the miss is another, and then the HHM is another, and then you have 1, 2, 3 at the end. So that's a total of 6 streaks, which are separated by a vertical line in your lab directions. And the lengths of those streaks are going to be 1. So the first streak has a length of 1 because there was 1 hit, and then the second streak is 0 because it was just a miss. And then the third streak has a length of 2 because there were 2 hits and a miss. And then each miss after that, it has a length of 0. So we have 1, 0, 2, 0, 0, 0. Those are your streaks, okay? So let's actually calculate those here. So I'm going to calculate the streaks by using these 2 lines of code here. So I'm just highlighting. The nice thing about having your file up here is that all you need to do is highlight the sections that you want to run and click run, and it will automatically run those for you. So there's a histogram of the shot streaks, and we can actually just, if you want, we can print out the first several values of those. So Kobe $ streak, or Kobe underscore streak. And then I'm going to put a bracket because I don't want all 133 of them or whatever. Actually, I wonder how many of them there are. So if we go up here and look in the environment, there are 76 of them. 76 streaks. So I don't want all 76. So let's put a bracket, and we're just going to look at the first 20. So bracket 1:20, close bracket. And that's here. So these are your streaks for Kobe Bryant. So his first streak was a 1, and we already discussed this. The first 6 was 102,000. And then apparently he got 3 in a row, and then he missed, and then he got 2 in a row, and he missed, and then he missed again. So you can actually reconstruct the data from just these streaks if you want to. So you now have enough information to answer exercise 1 and also exercise 2, because we actually have a bar plot now of the streaks and how many of them there were. So, you have how many zero length streaks there were, how many streaks of length 1, how many streaks of length 2, and so on. So answer exercise 2 from the this list of streaks.